Hello, ladies and gents. Nice to meet you all, those who I haven't met before, those who I have, nice to see you again. My name is Charles Ivie, and I'm a senior architect, senior graph architect in the Amazon Neptune team at AWS. And what you may or may not know is before joining AWS, I was working in graph technologies for about 12 years prior to that. And I was the co-founder of 3 different startups in the graph technology space, which I guess either means that I've been a very successful entrepreneur or a very unsuccessful one. You can take your pick. But prior to AWS, the product which I was working on with my friends was something called Graph.Build. And Graph.Build was and still is an attempt to bridge some of these gaps and really make friends between the communities and really make it a much more adoptable technology stack for everybody, whether you're interested in building things into label property graphs or semantic graphs. Yeah, I don't think there's going to be any slides. I think we're probably going to. Well, did you notice that? Is that what it is? Yeah. Well, so I probably just jump around a little bit. So first of all, I just wanted to, introduce the product. You can find it on. You can find it at Graph.Build at that domain name. Also, it is available as a ECR running service on AWS. It's available in the AWS marketplace, and it's fully compatible with Neptune and lots of other graph databases too, whether it's label property graphs or semantic graphs. So when I worked as a consultant and building things for about 10 years or so in this space, we learned quite a lot of the way that people need to work to actually build solutions for graphs and how to do it successfully. And there was a process that we went through to do that. And that process we kind of ended up calling the graph development life cycle. And it's very similar to the software development kind of life cycle as well, in that you design things, you design your graphs, you design your models, you build those graphs. And then once you've built them, you test them just like you would a code base. And then if your tests, well, some of them will pass and you'll come up with some new tests and some new ideas. And then you re-engineer that graph or that piece of software, that data architecture, if you like. You test it again and then you go again. And that cycle doesn't really stop. And in more modern renditions, when we see people building graphs, they might be building it for a Gen AI application, let's say, and then the names of the edges, the names of the labels and everything else, they're very, very key important pieces that you need to iterate and test very rapidly. So the graph development's life cycle is actually the most important thing to be efficient with. If you can be efficient with your development life cycle of anything, let alone graphs or technology or software, then you're going to be able to iterate and develop your technologies more quickly, of course, right? The most efficient factories produce in the end the best outcomes, and graph technology is no different. So Graph.Build is an attempt to create a platform so that everybody can collaborate in these things in the same place to be able to build design graph models for whatever graph database, more focused on the business purpose rather than the actual, rather than the technology stack, because most of the time, most use cases that need to or want to use graph technologies, most of the time you can achieve your goals with a label property graph or a semantic graph. It doesn't really matter, quite frankly. It doesn't matter to the businesses at the end of the day, quite honestly, a lot of the time. But there are great aspects and there are great features of all these technology stacks which can work well together. So I'm going to give you a little demo of what Graph.Build looks like. First of all, there's the studio, which is a no-code user interface for everybody to collaborate on. So if you can get all the people into a room together, or some subject matter experts and some technologists, some people who know where the data is, then maybe you can just work together to visually iterate and design your graph in a very quick way. Then there are these things called transformers. The transformers are ETL processors, which and virtualization configurations and anything else you really want to actually build graph models from source data or to point to it where it is. There's sort of CDC capabilities so that you can keep graphs up to date. There's virtualization capabilities. And there's also bespoke functions which can be run in the transformers to do more complex transformations or calling out to different services and that sort of thing. And you can upload your own functions as well. So think of it as your graph IDE for your graph development lifecycle and making that as visual as possible, because graphs are very visual and you don't actually have to be data scientists or ontologists, believe it or not, to design ontologies. And then we have these writers in Graph.Build. We developed a separate component, which is the graph writer, which will write to any language you want, and that'll be GQL in the future, I'm sure, as well, once the guys catch up with that. So that's basically the platform. As I said, it's running on AWS, so everything's easy to deploy there. So you're absolutely right. Those are some slides. So what does it look like to actually use Graph.Build? Well, if you could imagine that workshop scenario where you're working together and you want to design, let's say you wanted to design a ontology or a schema for a credit card transactions use case. There's lots that I've designed here. These are lots of different ontologies. They could be semantic, they could be property graphs. It doesn't really matter. You're basically designing a graph model. And in this particular graph model, which I'm creating here, there's credit cards, people, organizations, vendors, payment terminals, transactions, and locations, this sort of thing. Basically, designing an ontology can be a very easy visual process, right? If you're sitting around with domain experts and they say, well, we want to record data about credit cards, transactions, and where they're going to happen, it's not a very difficult thing to conceive that. And sometimes these things are totally overcomplicated by us as technologists. And there's no reason why domain experts can't be in the room and verify and say, yeah, that's the kind of questions I want to answer for these use cases. So it's a very easy and quick thing with something like this to be able to create new classes or entities here and say, well, this is a credit card, and a credit card is, is owned by, and there's nothing that's particularly groundbreakingly technological breakthrough type anything about this, really. All Graph.Build is doing is democratizing it and making it easy for people to use the technologies that we all know have our different specialities of how to use already, and putting a process around it that's workable and that's been practiced a lot. So transactions, I don't know, use a card, let's say. And we have our own sort of ontology, and I can generate an ontology like this and we can publish it, and you get your OWL file. But if you wanted, then it doesn't necessarily have to be a semantic graph. If you wanted, sorry, this is kind of looking about in a sort of property graph way, but we could also look at it in a sort of semantic world type view where we can see everything as triples rather than properties and edges and things like that on nodes. And then when you're happy with this kind of thing, you can then say, well, we've designed a bit of a graph and now we need to test it because that's the next step on our development life cycle. So we can say, well, I've got some data which is coming in on some files that are coming in from some sources of JSON or CSV or XML or something, and that's great, and we can stream those in and we can design actual graph models from that we could actually see some RDF data for. But equally, it might not be RDF we want to build. It might be a label property graph, and this will pipe anything into any target databases anyway. So that's one particular source of data, and that's lovely, and it's not very difficult to be able to say, for example, well, I want to create a person, but that person node is which is of type person, which is bound to the ontology we've just designed, that we know that the data coming in from this particular bit of CSV file, we will identify a person from a passport number, so we can put that in as the sort of template for that. We can apply that, and we could relate that to a card, and there's only one edge there that we've decided should be valid between those two things, so it's already populated, so we know that that's how those two things would be related. So our schema ontological model is being, thank you very much, is being replicated across into real data, meaning that when you actually get the data into the graph at the end, you know it's conformant to the ontology that you've agreed with the people who know what they're talking about in the room about your specific use cases. So again, this is not rocket science, it's just using the technology we have in more intelligent ways. And bringing some of these things together. So then that's great, but there's probably loads of data in loads of different SQL databases or Athena or a million different places. So in here, we can do that too. So I've created a little graph model for slightly different accounts, credit cards, and people who own accounts and credit cards. And in here, we can run a little query, and that query gives us some results. And those results, similarly to in the other diagram, we can drag the results in and decide what kind of node those things are going to be from the SQL database it's coming from. And all that's great, but we need to let's just get rid of that. But we need to actually test it and generate it. And for this particular one, okay, that's RDF, but I want to use exactly the same model, and I'd like to test it in a label property graph mode. So I can also create nodes and edges and that sort of thing. And because this is now a label property graph, maybe I want to actually put a property on an edge here. So I could also decide to make an edge property, I would say, I don't know, since this is so this is an edge saying something since then is string, and I'll just put in 2000 there for no particular reason. And we can see now that we're actually going to be building a graph which has a property on the edge which says since, and that's compatible with any target graph database. And we can have multiple lots and lots of diagrams together to go together, to join together, to create the same graph in the end. So, you know, this is a sort of main relationships model, which we see here, but there's also one specifically defined just for accounts and the properties for an account. So if you're talking specifically about modeling one specific part of the organization for your specific use case, you could have a small set of diagrams just to get right for that, test those out, get that into the graph. Semantic property, doesn't matter, test them both, tie in your Gen AI at the end, and your graph development lifecycle is super rapid, and you can get everything done in super fast time, such as I need to do, I think, because I've got about 2 minutes left, probably. 2, yeah. What else? So yeah, and the same applies to, so when you're creating a new model in here, I might choose this time I'm going to do a property graph, but this one, I want to use these specific schemas or ontologies. I've got lots of previously defined published schemas, ontologies, or maybe they're small pieces that go together, like the people, cards, accounts, little bit, and that bit, and that bit. And I'm going to use those to create an actual model for Neo or for Neptune or for Puppy Graph or for Tiger or whatever it is. And do it all in one place and democratize the whole process so that this is actually easy, not hard, because it's not hard, and lots of the concepts, quite frankly, are very commonly understood by normal human beings. So that's basically it. I think that's probably enough of an overview. Any questions?
I had a spicy question, but you almost answered it. So there are many ontology building tools like Protege back in the 90s, and Grapho, that was, it comes from Juan Saqueda.
Yes.
How does this differ? Are there major feature differences, or if this is simply better maintained and more usable?
There are lots of extended features which we haven't described or discussed, such as, yeah, the ability to add functions and things like that. So we can, for example, add lots of functions here, like there's various data transformation things you can do in here. So sure, there's a ton of other features, but the main key point is it provides a much more collaborative and easy to use way to create much larger models. So you can separate them into lots of small diagrams, separate them into use cases, and it doesn't matter whether it's a semantic or RDF graph, it translates into real data. So that's the main key difference. So let's say Protege, without you building quite a bit of software in order to point to other databases, won't be able to actually build models to test your use cases on. Right. So what I mean is, you know, you've got data in 5 different databases. Well, how are you going to actually test if your Gen AI use case can actually give you the result you need from that graph? You need to actually get the data in. So that what it doesn't do is it doesn't give you the ability to design your ontology and then bind real data into it and then put it in the graph in seconds, totally in seconds. And the same applies to Grapho. And these are great tools and they have their place for sure. But you could take those ontologies that are in there and upload them into Graph.Build and actually create graph models for any database. and really test it. So it's more about the graph development life cycle as a first-class citizen of what you want to do, not just ontology design.
Cool, thanks. That's informative.
Please.
Oh, thanks. In the semantic graph parts, which constructs do you support? For example, property restrictions, or like how to define the final expressivity of the graph that you?
Yeah, so there is a bunch of them, and soon I think it's going to be a pretty exhaustive list of like 99% of the most popular ones. So if I was to look here at, if I create a new semantic ontology, I don't know, I'll use that as, so you can also select like upper ontologies to use to guide your existing ontology. So I'll use this as an upper ontology. I'll call this model 2. And there's a sort of hierarchy aspect as well. You can see subproperties, subclasses of, and there's that hierarchical aspect. And we also assume inheritance. So I know it's not necessarily part of the W3C spec, but Graph.Build assumes inheritance is true in when it builds graph models, if that makes sense to you. But most importantly, if I was to say, I don't know, say one of these things, there's disjoint weird equivalent, subclasses of, annotation properties highlighting specific, you know, ones that you would expect. Cardinality, I'm pretty sure that they're going to be releasing cardinality into this shortly as well. I keep saying we, but really it's more they these days than me. It's me in my spare time, this project.
The first one was which OWL restrictions are supported? What if the data is updated on the sources?
So there are a few mechanisms for, I'll deal with the updated data first. There are a few mechanisms to deal with keeping data in sync. One is change data capture. You can turn on CDC so that it will actually update the graph dependent on the data sources in real time. So you can turn that on, that will work. There's also an update or insert mode you can set it to for any data source. So if you set Graph.Build into update mode, it will, for example, if you get a new set of properties for a specific node, it will update them. And if you get a new set of edges, it will delete the edges that were related to that node and insert new ones for it and that sort of thing. So yeah, updating graphs is dealt with in a pretty good way, I think. And then OWL restrictions, their cardinality, I think, is the main thing which they're about to put in. It's not an exhaustive list of restrictions that are in there, I think, in the UI anyway, but there's absolutely nothing stopping you, for example, uploading something which does have lots of restrictions. In here, I've uploaded, for example, FIBO and all this sorts of stuff. You can upload specific ontologies through URI anyway, so you can also import existing ontologies. Also, if you are designing an ontology and there's some specific construct which it doesn't support, there's no reason that you can't actually edit the actual OWL there as well. So if there was something that you wanted to do with it, you can do that and publish it anyway.